Good morning, everyone. My name is Gary Sealing. This morning, I'm pleased to introduce Sara Kimmich, who is a data scientist at ATA. She is going to talk about online rapid prototyping tools and remote collaboration. When we first started planning ETE, it was going to be an in-person conference, but now that so much work has moved to being remote, her material is extra relevant, I think, to a lot of people here. Many thanks to her and all of our attendees for their flexibility as we move this to a remote conference. Just like the other talks, we will be taking Q&A through Slack, so feel free to post your questions as you have them, and we'll have some time at the end to do that. So with that, over to you, Sara.
Excellent. All right. Well, welcome in, everyone. I think as people are choosing which rooms and talks and getting connected, we'll spend a little bit of time just going over the general and the basics. First off, because I can't actually see any of you, I'd like to get an idea of what kind of demographics we're working with here and get some information about your current remote working. So if you go to the Slack for room C, we should have a couple of poll questions that you should be able to see. It says that I am not allowed to vote as a host, although I have my own opinions about the right answers to these questions, but go through and answer these next 6 questions and we'll get a series of those up on the poll list, as in what's your preferred method of communication? Where does your team generally keep their documentation or notes for their code base? What day do you feel most productive of the week and what day is least productive? This may have, if you take a moment to reflect, that might have changed for you since you've gone remote and now have childcare. Every day is perhaps less productive than it was before. Yes, so you should be able to see a poll on the screen. I can see the poll. Can you see it? It should be inside of Slack.
It should be in, actually it's in Zoom.
In the Zoom, my bad.
Yeah, it's showing up, a couple of people are answering, so it should be there for some people.
Cool, well, I'll hold off, try to get those answers as they come in, and we'll just go ahead and get started. So we're going to cover 3 main things today that I think are really important. The first is how to solve the solution architect's halting problem, exactly what that is, and why it's so important to solve remotely. Second, we're going to go into rapid prototyping on scaling software architecture. If you have been in one of my talks before, you have done a form of rapid prototyping, or especially in a workshop of mine, you will have done rapid prototyping. But with this being a fully remote conference, we're focusing on exactly how you can do prototyping online with your customer and your team. And third, how really to keep the magic alive, how to keep the knowledge transfer and the cadence together. Tim, I do see your note on there's no 5 to 24 devs. That is probably my mistake, but if that's where you're at, that makes sense. A little bit about me. Yes, in the day, I am a data scientist. I work mostly in cloud computing. I do a lot of predictive analytics. Reinforcement learning is a specialty of mine. But it's what I do sort of after hours that I think is why I'm here. I really enjoy building large, distributed, inclusive hacker spaces, especially online. I would consider myself part of the digital nomad sort of group of software engineers. That's why I'm coming at you today from, you know, the enterprise starship, because we're all working remotely. I've worked remotely in the last year from 4 different countries and had the chance to see what it's like to try to get either people that have worked together for a long time or in hacker spaces or hackathons where people have never worked together, bringing them together and saying, how fast can we design a product? Can we get to a basic MVP and have that deliverable in anywhere from half a day to 2 days instead of a sort of projected period of 6 months of real development. I know that that sounds scary to some of us real developers that say, all right, look, it's going to take a couple of months to get the bugs worked out, but let me see if I can convince you a way of working practically and getting your documentation and architecture models to all be working together. If you have seen a more recent talk of mine, I think part of the reason I'm here is because at ClojureConj, I let everyone know that I'm working on a Clojure and cloud computing course and hackathon. If you're involved or want to be involved more in that, just hit me up on the Slack. I just wanted to make a note that that is not specifically what we're going to be talking about today. What we're going to be talking about is how to avoid the infamous black hole of unresolved issues. We're going to go over some forms of information flow. A lot of you, I will assume, work in some variation of Agile that you think works for you. That's excellent. But most of us live in reality where our best sometimes still puts us into these monolith or microstructure disasters that we really need to work out. And I think step number one of that, if you're transitioning from a co-located to fully remote team, is to resolve your team's solution architect's halting problem. Solution architect is either your formal role or a role that you're taking on at any time when you're sort of the conduit between the conceptual idea for a product from the client or the audience that you're trying to reach and your technical team. At any point, if you're trying to engineer the architecture that's going to make the engine run for your product, you would be considered a solution architect. And I say this is a halting problem because, in borrowing from mathematics, the halting paradox is trying to understand if there exists at least one input that can bring the entire machine to a halt. That's a paradox. We can't really know the answer, which I think is a little bit of an easier problem to deal with than the architect's problem, which is, how can I know? How do I know when there exists at least one way to build my MVP on budget and on time? Those are really fuzzy constraints sometimes that you've got to consider. And on that note, Martin Fowler really makes this point that doing the software architecture can be an incredibly social and fuzzy thing. Knowing sort of what your customer really needs to have delivered and knowing what your team can deliver are things that you can't have initial metrics for most of the time. But we want to be getting to this design payoff line. How do we get there as fast as possible in the design stamina hypothesis? You're going to know a lot of the language that I use is pretty like data-driven, process-y. And some of the words that I may use are going to be overlapping with other Agile frameworks. Just work with me here. Conceptually, I think that this will make a logical flow. We just want to figure out how do we work with the team that we've got on the time that we've got to create this MVP. One last definitional slide. If I say, if I make a reference to an MVP here, I am not referring to a specific Agile version of that. I'm just meaning whatever is viable enough to effectively deploy the product and no more. I might also refer to a minimally viable idea, which is a more holistic definition, particularly used in sort of more teams that have sort of non-traditional stacks that they're trying to implement, or in my case, teams where you've got to have the predictive analytics sort of heading the machinery. You want to define the problem, define the tools in the stack. You want to define the practical limitations of the MVP and also really the ethical limitations. Is there something that a space that we may want to not move into? Is there data that we may want to be curating before it even gets to our storage? Those are the kind of questions you need to answer to have a minimally viable idea that's a product that will continue to be used. This is how we're going to do this. This is rapid prototyping software architecture. Now, about 9 slides of this are going to be the same if you have seen my rapid prototyping talk specifically from ClojureConj. I can tell you this information is really buildable, and having a review will be good for you. But if you've seen this before, hold out for 10 minutes. If you're new to this, I hope this is really exciting to you. I teach rapid prototyping in corporate spaces, and it is successful, but I really enjoy teaching this at hackathons and like particularly to junior developers, because it's a way of getting around your own cognitive biases and your beliefs about what you can build. Because you are biased. All of us are biased. Our cognitive biases can range from assumptions about dependencies from the software that we're building to assumptions about the time that it will take our team to really build that. Those are things that are hard to scope. Fortunately, cognitive bias also tends to run on a function of time. You can get around biases and beliefs by truncating the amount of time that you have to flip into those as your sort of first response. Rapid prototyping helps us to do that, especially dealing with larger cognitive biases and anti-patterns that are in agile teams. I love asking this question, and just post it into Slack. Give me an idea of how long you think it took to build the first prototype of Google Glasses. I want everyone to give me their best guess. I know nobody owns Google Glasses. It's not the argument that I'm making, but okay, 5 minutes. All right, fine, that's ambitious. Anyone else? Few hours. Give me a couple more. I love always getting these. 3 years. Okay, yeah, to true product development, a couple of days, 3 months. I'll let these come on in. On average, I tend to get a response of an enthusiastic a couple of days to a couple of years. In reality, to get the very first prototype, minimally viable idea, it took 40 minutes. It took 2 separate sessions. Thank you, Frank, for your clarification there. And this is to get to a very minimally viable idea. Are we able to test with an audience, with a potential customer, all of the elements of the product design? And so this comes into place with Tom Chi's rapid prototyping system. Tom Chi was the tech lead for prototyping glasses, and he's the one that taught me this way of structurally working. The reason it took 40 minutes is because each rapid prototyping session takes about 20 minutes. And the first rapid prototyping session for Google Glasses, they made the assumption that the screen should have writing that was red, because that's highly salient for human eyes. However, if you have red and it's backlit, as it would be with Google Glasses, they found that that was really difficult to read. So they transitioned to blue and black text. I think it ended up being blue text ultimately. And that was a solution that they got to within 40 minutes that made it into the final design. So 2 clarifications on this point. When we're talking about initial rapid prototyping, we are not talking about getting to the nit and grit of really building a shippable product. That's going to be in the last section of this when we talk about making the magic last and working online. But the structure of rapid prototyping is incredibly important because it allows us to focus on observation, iteration, and documentation. If you work in a REPL, most of you have some access to REPL. You understand this way of thinking. It's much better to have a problem and test things rapidly and then to find a solution. It is much more ineffective to go through a process of deliberation and design before creating a solution. In the prototyping workshops that I usually give, I tend to start people out with pen and paper and doing UX UI design, mostly because pen and paper, I always like to argue, is the most free and open source software you're ever going to use. It's always available. Everyone knows how to use it. And it's a way where you can get initial designs in front of your customer and ask them questions about the way that it looks and feels. Transitioning to fully remote, you're going to want to use things like Lucidchart, InVision, Figma, whatever works well for your system, as long as you can dynamically change it in front of your customer. And prototyping is where iteration gives you the information that you need. If you do 20 sessions of 20 minutes, you can get that done in a single day, accounting for lunch break and 2 coffee breaks. That means that instead of having at the end of the day a single structural model or 1 or 2 ideas of what your architecture should be, you can end up with a range from 1 to 20 of those with slight variations that account for different risk factors that you've identified during the prototyping process. If you've spent some time thinking about evolutionary architectures, this is what they refer to in that as kind of playing the field. Right now, it's a very different world than it was 20 years ago. There's many different options, many different dependencies, many different communities of support for the systems that you want to use. You can't always guarantee that your first idea or your best idea is going to be the long-term result. If you spend the first day or two really identifying with the suite of tools available in the universe around me, what are some alterations that would be a solvable, minimally viable idea for my product, you can have those on hand and keep those in your documentation to lean on for future reference. It also allows you to take any designs that you've developed, any architecture designs, either repurpose them for other products or take a note when you find a dead end. Have a repository or a system that shows architectures that are unsustainable for specific problems so that your team doesn't revisit them in the future. Our prototype thinking is a completely actionable philosophy. I don't want there to be anything that is conjecture in this space. I want this to be a way where we maximize learning with minimum effort. That's why we keep our time boxes on. And then you want to have all of the information, particularly because we're all working remote here, having an out-of-body experience. And I'll explain a little bit more as to what that means in practice, but make sure that all of your communication mechanisms now, yes, I can communicate here and we can get on Slack, but anything that you have here, you need to evaluate the information that you're holding, even on sticky notes on your desk, and know if it needs to be placed into a repository or placed into a note page. The difference between observable and conjecture is observable is what is directly seen as true, and conjecture is what is argued as true. Let's be very frank about this. Any architecture diagram that I see that doesn't actually exist, that the team has not yet created or validated the dependencies for, is conjecture. And it will remain conjecture until that structure is created and verified. That is the only way that we go from observable conjecture to observable architecture. So 20 minutes, set a timer for 20 minutes. It's a Pomodoro. Get a group of about 4 people together online. You can do it with Slack or Zoom, whatever you're using right now as your process to do real-time collaboration and communication. 20 minutes aside, we're going to break it into 3 blocks. The first block is going to be choosing your prototype goal. Mostly we're going to be focusing on architecture in the second chapter of this talk, but when you're choosing a prototype goal, it means just make sure that everybody that's working on this understands the scope of what we're trying to deliver. Are we trying to deliver a specific C4 model? Are we going to deliver a specific UX UI landing page? What are we all going to focus our energy on? Then once you've decided what you're working on and what your problem statement or your hypothesis is, write that down and then proceed to, for the next 7 minutes, spend all of your cognitive resources as a team on developing a solution model. Get that solution model documented. It needs to be on the screen so that it can be handed off either to a technical team or to a more solution-oriented team in either side of the information transfer that we're making. Number 3, this is I always argue, the most important step. You're going to share the model that you've developed, whatever you've created in the last 10 minutes. You're going to share that information with a new user. This is somebody that has not been on your development team for the last 10 minutes specifically. They don't have to be completely new to the product idea, although that does help. But if you stand in front of them and say, we decided in the first 3 minutes that we would test this hypothesis or that we would create a solution to this architecture problem, and this is what we've come up with, have them identify without you needing to speak it over with them. If they can read through from the documentation you provide exactly what that problem was and what your idea to solve it was, and read that back to you, then you know that you created a communicable model of the architecture system that you're trying to mentalize as a team. this is essential because we all know that even our own attempts to create our best code, I come back to code I wrote 4 months ago, and unless I was communicating that in real time to someone else, a lot of times I don't necessarily have enough to know how it all works together anymore. The last step is to spend 5 minutes, let that novice leave the table or leave the Zoom space that you're in, and then spend the last 5 minutes revising with the pros and cons. If anything came up from your novice user, you can get a whole range of things from a novice user giving you probably the most important advice, which is, I don't understand the point of this product or this app. That's really meaningful advice. That's probably advice you want to have before you go into development mode. More likely, they're going to give you advice on maybe I would prioritize this set of information or this layout. And you go back into a revision mode. You go into a set of prototyping spin-offs until you're satisfied that you've got a testable hypothesis and a build plan that you're able to move from. That's basically the review part of my talk. If you have seen the rapid prototyping before, you're probably wondering, great, I've been using this, what's new? And this is where we come into C4 models. I didn't put a poll up on this before, but I assume that a lot of you are both aware of Simon Brown's C4 models and also maybe not actively using them. And I would like to argue that we should be. And this is how to make it most effective. If you haven't become familiar with Structurizer, this is Simon Brown's creation, where he's really trying to make us think about what are the levels of the architecture and how are we pairing our mental models to the actual physical models that we're delivering, and having C4 being a really nice architectural substrate for that. So it works on 4 levels: the context, containers, components, and the code. I loved his idea of thinking about this as like Google like Street View for your code, where you can go all the way out from the highest conceptual view all the way down to a specific street. I think that's a really nice way of describing the way that this helps you guide your team through the mentalizing of your architecture. So we have the groundwork where we understand that you need to set a timer for 20 minutes, work in those discrete boxes of what are we going to work on, how are we going to model it, does the model that I made make sense to anyone who wasn't there physically putting the lines on the paper or on the Structurizer model, and how usable is it? When we're prototyping, we're going to use Structurizer at the top 3 levels. Let's go to our cast of characters. For this case, maybe you're not the solution architect. You could be anywhere along this line. But let's assume that we're going to have 1 hour at the beginning of our MVP or MVI creation, where we make sure that all of these people are available online. Set the first 20 minutes to do a context diagram, which is a form of rapid prototyping. Your level 1, where you're going to answer who is using the system, where does information come from, and how is this information communicated? This is often the type of model that is developed by the solution architect or the development team holistically, more likely. Get this model, and your novice user for this prototype 20-minute session should be your client or should be a potential customer or audience for the app or product that you're developing. So you're going to spend 3 minutes stating to the team that we're developing a C4 model for this model. Have that be a 1 to 2 sentence description in words only, and then have the model that you create for 7 minutes be directly in Structurizer. Have that written description of what you think you're trying to model and that Structurizer description of what you're actually created. Give those to that novice or give that to that client and have a discussion from there as to, is this really your perception of how this customer interacts with this system, or are there additional, thank you, Daniel, I do love Structurizer, or are there additional systems or interactions with the system that we need to account with before we go deeper? That's layer 1. So you're only 20 minutes in and you've identified with the customer what your level 1 C4 model is going to look like, and they've agreed with you. That's awesome. That's a really good place to be. We're going to spend a second 20 minutes in the space between the solution architect and the technical lead or the technical team. You can always at any point assume that this can become a glob of, you know, specialized developers. But for the second prototype, set aside another 20 minutes, say thank you very much to the client or the novice, and say we're going to spend 20 minutes internally deciding what the container diagram would look like. So first 3 minutes, again, get your team together, get some coffee. 3 minutes, say, look, we're working on level 2 of the container diagram. We have level 1. How do we fill out what this looks like? Spend 7 minutes getting this container model together. I'm not going over a ton of the details about the way to make these models work. Structurizer has a lot of really good training. I use the free version. You can use a paid version to get more details or to be able to save it for longer. But the only question I want to ask here is, like, what is a web app and what are the points of interface in reality that we need to be building to? This is getting closer on the scale of almost to ground level. At this point, we're like no longer in the helicopter. We're like 10 feet off the ground. So 40 minutes into it, we should have an agreement with the client about like who's needing to interact and in what way. 40 minutes into it now, we've got that. We've also got what our initial container model is to the best of our understanding that we're going to build it to. And I think now we get to one of the most essential steps. This is where you no longer are going to be doing single prototype sessions. You're probably going to break out into smaller teams or into groups of individuals that are going to specialize in your different sort of specialities. For the teams that I work with, generally, I like to break it down with like front end, back end, data science, and have a prototyping session going concurrently for all of those. In that final prototyping session, you're going to get to level 3. For the component that I am responsible for, how are we going to structure this code? What are the language level modules? And how are these sort of dependencies interacting? At the end of that, you've got a single hour worth of work coordinating with your client and your technical team that gives you a basic model going up and down through the layers of the architecture that you want to be building. And what's really cool about this is it gives you sort of the complement to what Simon Brown is really aiming to do with Structurizer, which is making sure that the information is represented as close to the code as possible so that the code can represent the mental design that we were going for when we started. You need this if you're working remotely. We no longer can lean on our like post-it notes and our like dry erase boards to hold our models, and we shouldn't be, because those are unlikely to get updated. Keeping these models in the repository where this code is being developed is essential to making sure that those are the same thing. We'll talk a little bit more about that. I do like to say that I have this process of going from these C4 models. Those are always the first step if you've got a minimally viable idea that you want to turn into a minimally viable product. Naturally, I lean on evolutionary architectures quite a lot in the way that I think and the way that I design my products. If you ever are at a loss or saying, I don't know if there is another thing for me to prototype on, always prototype your fitness functions and just set aside a little bit of time every week to say, is there something in the sort of list of checkoff points for having a like nice hardened structure? What do I need to prototype on? What do we need to be hypothesizing? Where is our highest risk that we can rapidly reduce by focusing our team energies and strengthening both the mental model and the architecture and the code base all at once? So it's always good to put, you know, there's always quotes in these talks. So I thought this would be a great talk to put up because I've just given you this like really nice and easy way to like communicate from client all the way to your technical team. And everything will be fine. It'll be great, right? Because what could ever go wrong? I like to remind people that Herodotus definitely was not a developer based on this quote alone, because the one thing I always experience when I am starting to really go from the initial development to building larger, more intricate architecture is this listlessness for fear of what might happen. And we all have that. I'd like to play for you 1 minute of this clip. Some of you, I'm sure, have seen it, but if you have been successfully, if you have successfully developed a product or come into a system, this is how it feels.
Just one feature. Why is this taking 3 years? Look, it's not that simple, all right? I have priorities, my team has deadlines. I'm still not understanding this. Why is it so hard to display the birthday date on the settings page? Why can't we get this done this quarter?
Look, I'm sorry, we've been over this. It's the design of our back end. First, we have to build a bingo service. See, bingo knows everyone's name-o, so we get the user's ID out of there. Then from bingo, we can call Papaya and MBS to get that user ID and turn it into a user session token. We can validate those with Omnop, and then, once we have that, we can finally pull the user's info down from Raccoon.
Yeah, but couldn't the Raccoon team basically just...
No, Raccoon isn't guaranteed to have that info. Before we do this, we have to go to Wingman, do a query to see if the user's willing to take it to the next level, or if they're just playing the field. Now, Wingman is cool, but he doesn't store any user info himself. He has to reach out to other user info provider services, like RGS, Barbie Doll, Ringo2, BLS. But how does it know what all the user provider services are? Well, for that, it has to go to Galactic, all-knowing user service provider aggregator. And while Galactus has omniscient knowledge of all current user info providers, it doesn't have future sight or knowledge of past user info providers, so it expects a time range. To get all the current user info providers, we need to pass a time range with the current time and a time representing the end of the universe, which we get from EKS, our entropy chaos service. EKS.
All right, hopefully that came across. I know a lot of you have already watched this clip. I know it's been going around. I love it so much because I love the idea that EKS is an entropy chaos. So let's look at questions here. Looks like the C4 context containers components, concepts or content within context. That's like an interesting technical question. I love this whole thing.
Display the birthday date on the settings page.
Let me see. It makes me have to re-present from here. But let's get back on track. If any of you have had that experience, just like write it in the Slack if you relate, because like I totally relate to that experience. Because that's what happens when we're building these massive things. And up to this point, I've kind of been talking about the nice, crisp version of like having a team and building a product from scratch. This is also like the really exciting, like going to a hackathon and like we create a repository and we just start getting going. A lot of us have been working on projects that are either legacy to us or have been existing long enough that they've become this bundled mess. And now we're trying to deal with this fully remote. If you have a better metaphor than this, do let me know. I'm always looking for a better one. But as a software engineer, communication is always our biggest problem because it's like we're all trying to build this like massive, complicated like car in the dark. We all have blindfolds on and we can only get it to work by talking and communicating with each other. And it's been great to have the information radiators that we've had and these agile processes, but working remote is like a totally different world and we're losing a lot of the saturated sort of information that's sitting on paper and pen in our spaces. So you're going to be one of these three things, right? You're either this existing team with an existing code base, an existing or new team with a new code base, or you're like a lone ranger, or you're trying to contribute to open source, which I think is super cool. Most of us are like one or all of these things working on different projects. Another thing that I know about all of you statistically is this. You spend on average 40% of your time learning new technologies and 10% of your time on documentation. And I think 100% of you are working from home, if not today, in general, moving forward with the situation. And another constraint are all of these things, or these are what you really have to consider if you've got a real functioning product, right? Like, what is the best way to do that? That's like a really hard question to ask when you're just trying to maintain a system and make sure that you can put out fires when they come up. What are the potential problems that come up? Is there, like, what's the memory CPU usage? How efficient is this? What's the best way to store these systems? And particularly, I love keeping this question up of how can I explain this in a non-technical terms that anyone can understand. We have some solutions for these. Again, when I do this in workshop mode, it's usually like half a day or a full day. And we go from this, like, here's this wonderful idea of rapid prototyping into the dirt and the mud of this is what this type of architecture looks like. I can't get into those details today, but I'm going to try to give you some more insight into what that would look like if you want to sort of workshop on your own at home, or just building projects with this way of thinking moving forward. I insist that if you're trying to work in this way, you should have a modular repository where you've got a README document that gives you the basic information, and then, as has been suggested for decades, keep your business documentation or your business logic as separate from your technical stack as possible. Design your file structure in this way with your context, container, and component diagrams in these specific folders, because they should, your C4 diagram should always be sitting in the spot of your repository where it is directly relevant. If somebody wants to open up a file, they should be able to open that up, and that should be their map to understanding where they are and where they can go up or down to get to the level of complexity that they're trying to be at in development. The last part here is keeping your mobbing notes in the subcomponent that is specific to the like pair or mob programming that you're doing. This is essential because when you're working in this way, right, the reason is that it makes it modular and allows you to take something that is successful and sort of wrap it up in a bow and move it over and start a new project or a system or contribute to open source. And when your mobbing notes are kept specifically in the repository of the subcomponent, the current state of knowledge for your entire team should be represented in that when it gets transferred over. Asynchronizing development. So now we're trying to see, I know a lot of us work in agile ceremonies, and I think half of us are okay with it and enjoy it, and like half of us seem to secretly hate it and think that it's a waste of time. I don't know. I'm on both pages depending on the day. But I think working remotely allows you to really prioritize asynchronous development. And what I would argue you should give a shot in is like keep all of your ceremonies to the best that you can in this new remote world that we're working in, but have a development sync at least once a week, if not once a sprint. Now, what does a development sync mean? It's exactly this. Choose a single point in time. Right now, for all of my teams, that point of time has been agreed to be 4 p.m. on a Thursday. 4 p.m. on a Thursday. Everyone agrees to have updated and merged their code. All of our integration tests are working, theoretically. If everything is working, then you update the C4 model if there have been any changes at the level of your production. And then you go on to update the scope. So for us, that means once we have a shared communication and any change at any layer of that C4 model has been changed on every impacted or dependent layer, we've got a team understanding, and we can go directly to what JIRA tickets need to be updated, sort of moved. It is way faster than like traditional like code reviews and retrospectives. And while there's a huge social component to that, this really gets around the risk of like, does it work? Does the system work? And do we have the most updated model of the system in the repository? And for this to work, you have to have every person that interacts with the system, including project managers. I keep in mind, I was reading, I think it was the Phoenix Project where this quote came from. If you do remember exactly where this comes from, let me know. But the most predictive element of whether or not a project was successful according to the Phoenix project was whether or not the product manager had made a Git commit, not necessarily the rate of Git commits by the developers. Meaning sometimes things fail because we're not having those shared information radiators. And this is your new model for that. Keep all of your radiators inside of your repositories. Keep it directly next to the code and make sure that all three of those levels are updated. A lot of you do or have done when you're working co-located pair programming and mob programming. I'm really interested if you can tell me on Slack, are there any tools or systems that you're using right now that have made that really thrive as you've been working remotely? My team does remote pair and mob programming. You can just use Zoom or Slack and get push and pull. But why this is important is because when you've gone remote, there's always been an issue of senior developers need to get the job done. Junior developers don't have the opportunity to learn the state of the system before it moves on. Pair programming and mob programming fix that problem. First of all, because everyone's involved. I think that the stats show up for the efficiency of pair programming over working separately, particularly for junior developers. I would say that it's better than code reviews. It should substitute the time that you do code reviews because you can catch those mistakes in real time. And you have clearer code. You write better code initially, and you can have the researcher updating the C4 model when needed for driving. And just a final note, yeah, put up any tools that you love or are super interested in. I put some of the most generic tools up there. Really anything works. If there should be nothing prohibitive beyond like access to screen share that should allow you to do pair or mob programming. I love remote mob programming. Remotemobprogramming.org does have a ton of really good advice. My recommendation for this is that you use mob programming, particularly on things that you identify as really high risk. So that everybody has the highest rate of learning. You can train your junior developers quickly, and it improves your documentation because you do have 5 researchers. And I would recommend for both pair and mob programming that somebody is a designated note taker. Here's a little addition to that is cool. If you have a note taker, I recommend this as a system of accountability as you're all working online. I don't know if you all know about FocusMates, but a lot of developers do because I run into them all the time while I'm using it. FocusMates is a structure where you just pay like $5 a month. You can get a couple of free sessions as well, but you sit down in 1-hour blocks. You have your video up so people can see your face, and you tell a stranger online, like, this is what I'm trying to get done, and they tell you what they're trying to get done. 50 minutes later, a little chime comes up and you tell them what you got done. That sounds a lot like that novice user, you know, for rapid prototyping. So having this system of accountability, not only to the rate of the work that you're doing, but the quality of communication everywhere in your development process is really what I'm trying to speak to here. We get a lot of the same advice in the last couple of decades. It's just like, how do we improve the way that we're thinking these things through? And you can do that by just removing developer speak or removing sort of cyclical thinking inside of teams. Have an outside team member come in and just like, hey, this is the dependency we tried to fix. This is an error message that we tried to fix. And like an hour later, tell that stranger, this is where we got. Write down that exact message in your mobbing notes. Perfect way to carry that. Oh, that's interesting advice, Fred. I like that. So here's my action statement if you're like one of the 3 or taking on the role in one of these 3 types, right? So if you're creating a new code base, it's like very easy for you because you get to start from tabula rasa. You say, all right, I'm going to prototype my C4 models. This is going to take you about an hour to get the initial design. maybe another hour, hour and a half of prototyping to really make sure that there is an understanding all the way down to the lowest level of those C4 models all the way back up to the top. And that can be easily improved as you dynamically deliver your product. Number 2, implement remote and pair mobbing. Like, just do that now. I would set aside, I literally set aside an hour and a half block, 4 days of my development week to do pair programming so that all of my team members do stay technically in front of what we're trying to deliver. And then have dev sync model each time. Choose that specific time where both documentation and code have to be refactored and delivered. If you're trying to scale an existing code base using this, your first step is going to audit your remote team cadence. Honestly, you're going to need to understand, why are things working differently now? You can ask questions like I asked you all at the beginning, which is like, when are your most and least productive days? Generally, I'm going to tell you, like, your least productive day is probably the best on average for your team. It's probably a great day for you to do your development syncs, because you're less likely to have people pushing code on those days, pushing novel code. Gives you time to integrate, and it lets people understand that we're paying attention to the tides and flows of what you need, but we're still getting work done. The second is the audit architecture for scalability. So go through and do the same thing as you would with a new product, but go through every level of your system and say, what is the C1 through 4 of the diagrams that we're trying to create here? Obviously, I'm going to tell you the same thing: implement remote and pair mobbing. Fourth, dev sync. It's the same process. Once you get into a cycle of making sure that the mental map, the conceptual models, and the code are all the same and in the same place, things get easier for you. And if you're a Lone Ranger or like an open source ninja, or if you're like, this is cool, I don't know if I want to go through the work of implementing this in the system that we currently have running, totally fine. I challenge you to do this. Like, just go find an open source project that you're super interested in and try developing the C4 models for it. Really interesting if you can actually get the original developers involved and have them be sort of your novice, or the person that you test out your understanding of the model with. Then you're going to audit it for scalability if possible. How would you restructure this if you were going to make it more usable to your specific needs? And then 3 is just like join remote pair and mob programming groups. What's cool is I've worked with teams that have worked together for several years, and also on teams where like we've intentionally randomized such that no one has ever worked on the same prototyping team before. And they get to the same rates of acceleration within 1 or 2 days. You're really changing the way that your communication style in your team works when you're working on these compressed deadlines, and having accountability to non-technical people at every point in your technical development process. So with that, I really do hope that I've given you, not all of this was new, a lot of it wasn't, but it's packaged in a way that helps us with some of the new pains that are more apparent that we're all remote. Doing my best to keep my teams out of black holes of unresolved issues. I hope that you're doing the same. And let's work on ways to continue doing that together. I always like to end on this note because, yeah, I do work in a corporate space, but beyond like data-driven development, I also like working with the idea of like joy-driven development, Like, I love going into spaces where people have never developed an app before, teach them rapid prototyping, and in like 1 to 2 days, they've developed a product and they wouldn't even consider themselves a developer before. That's really cool. And if that kind of thing is exciting to you and you do have a lot of experience, then come talk to me. I know a lot of people trying to do really cool tech for good open source work. And we can use some more expert assistance. And all you have to do is set aside literally like 5 minutes of your time as an expert or a novice inside of these prototyping cycles. A huge thank you to ETE. This conference has been like very cool so far. Lots of big names. I was very intimidated to be part of this lineup, and really glad for the kind of communication and the ideas that are coming out of it. And I'm interested to see sort of where you guys take this and where this is going to go next year if you all take on some of these methods. If you want to get in touch with me, I run once a month a community prototyping session that is totally online right now, meaning if you want to be an existing team, create a new team that comes together, or work as a lone developer. My apologies, the trash can man is going outside. Such is the joys of working remote. If you want to be on a development team or work as a lone developer that can assist a new team and really get into the grit of using this in real time, join one of my prototyping sessions. The next one is going to be May 3rd. It's free. If you work on an open source project, we tend to choose specific things that we're focusing on. And right now we're focusing on the resiliency challenge, which is a like multi-month hackathon around COVID-19 problems. That sounds exciting to you, like a way to spend your time working on something that's good and meaningful for the world while getting better at your technical leadership and rapidly building MVPs and MVIs. Join me there. It's cool work and they're really cool people. I work around the world, so our prototype sessions are usually like 30% people from London, like 20% people from DC, and then like people from everywhere. It's an awesome way to get to know people. On that note, that's going to be it for my talk, which means we've got a couple of minutes for questions. So there probably are some. There's definitely going to be, if not questions, comments. So just let me know. I do want to speak a little bit to Fred's idea of like, don't ever create a working throwaway prototype. I mean, I think that's true, but then there's also the idea of like, you're always going to throw away your first model, right? That's like a direct antithesis to that belief. I think, maybe that's just in the way that you label or communicate your design process to your client. A working throwaway prototype, yeah, that's interesting language. Yeah, there's a discrete line between prototype and production. If you're afraid that what you've produced is not going to go into production, maybe don't share it once it's got code attached to it. Don't share it right away with client. Share the architecture models, certainly. If there's anything else, we've got about 5 minutes, and I know there's another talk coming up, so if you want to like take a like coffee break and whatnot, go for it. But if there's anything else, I think Fred has more to say. I do think I missed his point a little bit, but yeah, anything else?
Yeah, it looks like Danny has an interesting question here. What do you do about this documentation being maintained under schedule pressure from client deliverables?
Right. I love that question. So I think an issue is that like documentation is such a, you know, it's kind of a 4-letter word for developers because it means documentation is usually what goes in place of good design. Generally, a well-designed code doesn't need documentation, right? That's always the argument that we hear. And I think what we should be doing instead is really simplifying what we mean when we're talking about documentation and keeping up with that grind. I really think the only thing that you should be actively maintaining on a weekly or sprint sync basis is the C4 models. You don't really need to be actively updating anything else beyond your code base and the related model. Your code itself should be both written clearly enough and sort of, if needed, have the internal commentary to support itself. If you are getting asked to do additional documentation, kind of push back on your sort of management team and cycle. One thing that I've seen work really well is taking your sprint design and using that developer sync and placing that exactly 1 to 2 days in front of where your sprint would traditionally end and you'd go to your retrospective. Generally, that's a really nice way if you're dealing with all of like overhead or interacting with your product managers. You can say, look, we've created a completely asynchronous, verified, validated way of checking both our code and our entire architecture in a way that you can look at, but we don't need to have FaceTime in order for that to work. So that might be a way. I do like Daniel's question of like, you drop all architecture that's not deliverable to the customer. Yeah, just don't have unnecessary documentation. I think that we could burn so many of the Post-it notes in our office spaces and be able to move on more efficiently, not less. If you've got a bunch of documentation that it's difficult to maintain, yeah, do let it evolve out. Yeah, I do like Fred's point of view. Yeah. And I also, it was part of this does sound like it's just a matter of like really having a discrete boundary between like what are you showing management or the client and what's under the hood, right? And it's really like they only need to see what they're going to be interacting with. Let's see, from getting the same documentation treatment of being evolved out. They should, I mean, they cannot get evolved out, right? If you're doing the C4 models based on the architecture that you have, if that architecture exists, so will the C4 model for it. If you're doing this like really nice modular repository, if some component or subcomponent needs to be added or removed, you can do that really easily. And just in that development sync, update the models accordingly. So they are, it's like conceptual CI/CD.
All right, so I think we're just about out of time. The webinar is going to auto end at an hour. We're going to set up an Agile channel in Slack because it seems like there's some good discussions around this. So if anyone's interested in that, I'll post a link in the Room C channel and people can join and continue.
Awesome. Cool. Well, thanks so much, guys.
All right. Thanks so much for speaking. That was great.